All right, we are now in Chapter 5, Lesson 2, called Ratio Tables. So for this lesson, please open your book to page 198, and we will write in our learning target, which is, I can make and use ratio tables. So last lesson, we talked about what is a ratio, which is a comparison of two things. Today, we're going to talk about ratio tables, where we can set up a little table to compare lots of different ratios together. So at the top of page 198, it says two ratios that describe the same relationship are called equivalent ratios. You can find equivalent ratios by doing one of the following. You can add or subtract quantities in equivalent ratios, or you can multiply or divide each quantity in a ratio by the same number. Then it says you can find and organize equivalent ratios in a ratio table. So the first word we'll write down is equivalent ratios. Oops, I missed the T on that one. The word equivalent means equal to. So if I'm going to write equivalent ratios, I have to write ratios that have the same meaning. So I'm going to put ratios with the same meaning. Basically, if you think about the word simplifying, you are working with equivalent ratios. If I have a ratio that's 1 to 2, an equivalent ratio to that would be 2 to 4. Even though I'm using different numbers, 1 to 2, if I simplified or if I scaled up, would be the same as saying 2 to 4. They would both be 1 to 2 if I simplified. So today we're focusing on ratio tables, so I'm going to put that on here as well. And I'm going to box it in. So on our test, if they're asking us to complete a ratio table, we know that this is the lesson that we're going to look back to try to do that. So let's move ahead and go into our examples. So we have example 1. Says completing ratio tables. Find the missing value or values in each ratio table, then write the equivalent ratios. So two things we must do. We must complete the table, and then we're going to have to write out our ratios separately. So for this particular table, the top represents our pens and the bottom represents our pencils. So I'm going to draw a line to separate those two. And then it looks like I have 3 different columns. I made a little bit too many, but that's okay. The numbers that are given to us are a 1 here and a 2 here, and then a 3 in this box and a 9 in this box. They don't actually give us anything over here. So if I were to take and write the ratios, these are called pens to pencils. So if I have 1 pen, I would compare that to 3 pencils. So I can write that as a fraction, 1 to 3, 1 over 3, or 1 to 3, 1 pen to 3 pencils. My next ratio would be 2 pencils to a certain number, 2 pens to a certain number of pencils. So this number down here is kind of a mystery number. And then my last ratio is some number of pens to 9 pencils. So I want all 3 of these ratios to be equivalent ratios. They have the same meaning. So if I'm going to scale 1/3 up, so 1 becomes a 2, I could multiply by 2. So 1 times 2 would give me 2. I also have to do the same thing to the bottom. So 3 times 2 would give me 6. So this missing number here would be a 6. Then if I take this 1/3 and I want to get up here, well, let's think. How do I get from 3 to 9? Well, do I multiply by 2? I don't. I actually multiply by 3. So if I take this one and multiply by 3, I have to do the same thing to the top. So 1 times 3 would give me 3. 3/9 is the same as saying 1/3. So this mystery number here would be a 3. And we have completed our ratio table, and we have all 3 of our ratios written out. Moving on to question B. Question B is comparing dogs to cats. So we'll draw our line, and this one gives us a 4 here and a 6 down here. Then it gives us a 12 down here and nothing on the top. And lastly, it gives us a 24 on the top here and nothing on the bottom. So let's start by taking our ratios out of the table. The first ratio they give us is 4 dogs compared to 6 cats. Then we have a mystery number of dogs to 12 cats. And then we have 24 dogs to a mystery number of cats. So once again, we'll try and figure out these missing pieces by asking, okay, we've got a 6 here and a 12 here. So how do we get there? Well, 6 times 2 would get us to 12. So I'm going to do the same thing to the top. 4 times 2 would get us 8. So we have 8 dogs for every 12 cats. So our mystery box here would be an 8. Next, we have to get to this 24 on the top. So let's talk to the top over here. Well, how do you, 4, get to this 24? Well, to get from 4 to 24, I have to multiply by 6. So 4 times 6 would be 24. So I have to do the same thing to the bottom here. 6 times 6 would end up getting us a 36. So that's how I get my mystery number of cats. So we have completed our ratio table, and we have written all 3 ratios outside of that table. You can go ahead and pause the video now and try the first 2 on your own at the bottom of page 198. Okay, so for number 1, you're comparing plantains with bananas, and the ratios there, the missing boxes should say 8 and 9, 8 on the top and a 9 on the bottom. So our ratios would be 4 to 3, 8 to 6, and 12 to 9. And number 2, you're comparing euros to dollars. The mystery boxes, the first mystery box would be an 8, and the second mystery box would be a 40. So I'm assuming that means the bottom one there is going to be an 8, and the top one at the end will be 40. Your ratios are 5 to 4, 10 to 8, and 40 to 32. Okay, moving right along to example 2. It says making a ratio table. Looks like we're making an actual real life situation here. So we'll switch colors. For example 2. Says you're making sugar water for your hummingbird feeder. A website indicates to use 4 parts of water for every 1 part of sugar. You use 20 cups of water. How much sugar do you need? Now, in this particular question, it doesn't say that we have to use a ratio table. And honestly, the numbers are so easy here that we're dealing with that we may not need to make a ratio table. So the important information is we're talking about a hummingbird feeder. And we're trying to mix the water with the sugar to be able to feed the hummingbirds. It tells us that for every 4 parts water, or 4 cups of water, we are going to need 1 part sugar. So our ratio would be 4 to 1. Then it says that we are going to have 20 cups of water. And so we want to know how many cups of sugar. So if I look at some ratios here that are created, I see 4 waters versus 1 sugar. So I have 4 water. So if we can say the top stands for water and the bottom stands for sugar. 4 parts water for every 1 part sugar. I now need to get 20 cups of water, and I have this mystery number of cups of sugar. So if I take my 4 and I figure out how do I get from 4 to 20, well, I multiplied by 5. So I have to do the same thing to the bottom. So I'm going to go 1 times 5, which would give me 5. So my mystery number of cups of sugar would be 5. So my final answer is 5 cups of sugar, which seems like a lot, but those hummingbirds love their sugar water. You can pause on the bottom of page 199. There's 2 more on your own, so go ahead and try them out. Okay, so for number 3, the answer would be 6 cups, and for number 4, the answer would be 3 quarts. Turning the page now to page 200, they're again looking at a ratio table for a new situation this time. So I'll switch colors. Example 3. The question says, the nutrition facts label on a box of crackers shows that there are 240 milligrams of sodium in every 36 crackers. There's 2 different questions they're asking us here. Part A says, you eat 15 crackers. How much sodium do you consume? And then B says, you eat 21 crackers. How much sodium do you consume? So let's pull out some important information. We're talking about sodium in crackers here, and it tells us that there's 240 milligrams of sodium in 36 crackers. So that's the overall arching important item here. So A is asking us to figure out if we have eaten 15 crackers, how much sodium? So I'm going to put a question mark. How much sodium in 15 crackers? So we can make a little ratio table here. The top maybe we'll label sodium. So we'll put that here. And the bottom crackers. And I'm not sure how long we're going to need to make this table, but we'll just start it out like this. And I'm going to make my sections a little bit bigger just in case I have bigger numbers to deal with in this one. So the first thing we'll fill in is the information they give us. So it's 240 milligrams of sodium in 36 crackers. Now, one thing I'm noticing here is that 240 versus 36, that is not in simplest form. So it may help us to try to get it down to simplest form in order to figure out our final answer here, which is trying to figure out how much is in 15 crackers. If we wanted to get from 36 crackers to 15 crackers, we wouldn't be able to divide 36 by something to get to 15. It just wouldn't work. So what we're going to have to do is take 36 and start cutting it into something that actually will go into 15. So let's just say, for example, we wanted to cut these numbers in half. Let's divide by 2. So we do both divided by 2. So 36 divided by 2 would be 18, and 240 divided by 2 would be 120. So 240 milligrams of sodium in 36, so there's 120 milligrams of sodium in 18 crackers. Well, we're still not at 15, so let's do that again. Let's cut it again in half. Let's divide by 2 again. Well, 18 divided by 2 would give us 9, and then 120 divided by 2 would give us 60. So there are 60 milligrams of sodium in 9 crackers. That's still not going to get us to 15. Interesting. Well, let's go one more time, but this time instead of dividing by 2, let's divide by 3, because 9 cannot be divided by 2. So if I divide 9 by 3, I end up getting 3 crackers. If I divide 60 by 3, I end up getting 20 milligrams of sodium. So nowhere in my chart do I have 15 crackers. However, if I kept this going one more section, could I get from 3 to 15 by multiplying by something? Could I get from 3 to 15? Well, I could. 3 times 5 would get us to 15. So then if I do the same thing to the top, 20 times 5, I would end up getting my milligrams of sodium. So 20 times 5 is 100, and that is going to be our final answer for question A, because I just used my table to figure it out. So how much sodium? Well, there's 100 milligrams of sodium in 15 crackers. So notice what we did here. We divided and divided and divided, and then we multiplied back up. So you don't have to keep doing the same thing every time in order to find the target answer that you're looking for. Now, question B is asking us, what if you eat 21 crackers? So how much sodium in 21 crackers? Okay, well, let's take a look at our numbers here. I have 36 crackers, 18 crackers, 9 crackers, 3 crackers, 15 crackers. I don't have a 21, but if I look at all my numbers of crackers, I do have a number that could go up to 21 by multiplying, and that's the 3. If I take 3 crackers and I multiply by 7, then I'm going to end up getting 21. So 20 grams of sodium, milligrams of sodium, over 3 crackers. If I multiply that by 7, I'm going to end up getting 21 crackers on the bottom, which is the target number I'm looking for. So 20 times 7 will give me my number of milligrams of sodium. And 20 times 7 would give us 140. So my final answer to question B would be 140 milligrams of sodium. So this is how you use a ratio table to find numbers like 15 and 21 that aren't exactly with what information they give you. And we've got one more quick example here. So let's go ahead and switch colors one last time, and we'll talk about example 4. The bottom of page 200, it says using a ratio table again, you mix 3 pints of yellow paint for every 4 pints of blue paint to make green paint. I don't know why they couldn't just have bought green paint in the first place, but that's neither here nor there. You use 10 pints of blue paint. How much green paint do you make? So we're talking about paint this time. So we'll write that down. And the important information is they say that there are 3 pints of yellow paint to every 4 pints of blue paint. So our ratio here would be 3 to 4. 3 represents the yellow, 4 represents the blue. And then it also tells us in that we use 10 pints of blue. And the question is neither yellow or blue. The question is asking us, how much green paint do you make? So if you remember from elementary school, if you learned in art, that if you mix yellow and blue together, you end up with green. That's where the green is coming from. So if we talk about this in terms of a ratio table, we can label the top as yellow paint. And then let's go ahead and label the bottom as our blue paint numbers. So we'll make a little ratio table here. And let's start out with what they've given us. So every 3 pints of yellow gives us 4 pints of blue. It's a small column, but we're going to start there. And we want to end up getting 10 pints of blue. So this bottom number, we want to be a 10. So kind of like example 3, we're going to start by cutting this in half, divide by 2. So half of 4 would be 2. Now 3 doesn't cut in half very nicely. However, it's just going to be a 0.5. So half of 3 is 1.5, because if I added 1.5 plus 1.5, I would get to 3. So now we're at a number 2 that could multiply up to a 10, because 2 times something can get us to 10. So if I took my 2 and I multiplied by 5, I would get to my 10. And 10 is my target number of blue pints. So that's going to give us this mystery number of yellow pints. What I have to do now to get there is to take this 1.5 and multiply it by 5. Thankfully, you can use calculators again in this chapter. So you're going to be multiplying 5 times 1.5, and that's going to give you that top number. And that ends up giving you 7.5. So if I have 10 pints of blue paint, I should be using 7.5 pints of yellow paint. If I mix these pints together, I'm going to get green. So to get my green color, I have to figure out how many total together this would make. So I have to add my 10 pints of blue plus my 7.5 pints of yellow, and I end up getting 17.5 pints total of paint, and that's going to create green paint. So my final answer would be 17.5 pints of green paint. You can pause and do the last two on your own if you'd like, numbers 5 and 6. So number 5 is 160 milligrams, and number 6 is 12.5 pints. And that is the end of Chapter 5, Lesson 2.